Hi, welcome to my trigonometry class. If you have taken geometry before, then you will enjoy this class in trigonometry. Trigonometry is a branch of mathematics that deals with the measurements of triangles. It is also said to be a branch of geometry that deals with the relationships between the sides and the angles of triangle. The word trigonometry was derived from two Greek words. The first is trigonon, which means triangle, and the second Greek word is metron, which means measure. Trigonometry can be traced back as early as the second millennium BC in Egyptian mathematics as well as in Babylonian mathematics. The Babylonians were believed to have invented the division of a circle into 360 degrees because 360 degrees is divisible by 60, and the Babylonians used base 60, or they use 60 as base of their sexagesimal numeral system. The field trigonometry formally emerged as a field during the Hellenistic period in 300 BC, with the applications of geometry to astronomical studies. But trigonometry became an independent field during the Islamic period, when all the six trigonometric functions came to be known. But the Greeks were said to be the pioneers of trigonometry, with Euclid as an important figure, and is famous for his book Elements. But the thing to remember about trigonometry is that trigonometry deals with the measurements of triangles. And our course is called plane trigonometry because we will deal with triangles in a plane. A plane triangle is a triangle that can be drawn in a plane, specifically in the two-dimensional plane or the Cartesian plane. The triangle, like all the other plane figures, is associated with two measurements. The plane figures, like triangles, are said to have two measurements that can be obtained from them. One is the perimeter, and the other measurement is the area. All the polygons, including triangle, have these two measurements, perimeter and area. A circle is also a plane figure, but it doesn't have a perimeter. But instead, a circle has what is known as circumference, but a circle has also an area. So a triangle is a polygon bounded by three lines, or more particularly bounded by three line segments. And this is an example of a triangle. It is bounded by three line segments, 1, 2, and 3. And a triangle is a closed plane figure. A triangle is a polygon bounded by three line segments. In general, a polygon is a closed plane figure bounded by straight lines or line segments. And the minimum number of lines to construct a closed plane figure, a closed polygon, is three line segments or three lines. And the polygon that will be constructed using three line segments or three lines is a triangle. The triangle has 6 parts, but many people or most students would say that a triangle has only 3 parts. No, a triangle has 6 parts. The 6 parts of the triangle are the 3 sides and the 3 angles. Again, a triangle has 6 parts. Any triangle has 6 parts. Those are the 3 sides of the triangle and the 3 angles of the triangle. The angles of a triangle are usually denoted by capital letters of the English alphabet, and the sides opposite these angles are denoted by or represented by small letters of the English alphabet. Again, we said that trigonometry is a branch of mathematics that deals with the measurements of triangles. And triangle is a polygon, a closed plane figure bounded by straight lines or line segments. And we said that a triangle has 6 parts, the 3 sides, and the 3 angles. We also said that the angles of a triangle are denoted by capital letters of the English alphabet, while the sides of the triangle are represented by small letters of the English alphabet. Now we will identify the angles and the sides of our triangle using capital letters for the angles and small letters for the sides. For this angle, I will represent the angle at this vertex by capital A. So we can say that this is angle A, the angle at vertex A. And this angle, I will use capital letter B to represent this angle of this triangle. So this is angle B of this triangle. It is the angle at vertex B of this triangle. And the third angle of this triangle, I will use capital C to represent the third and the last angle of this triangle. So the 3 angles of this triangle are angle A, angle B, and angle C. For the sides opposite these 3 angles, I will use the small letters of the English alphabet to represent the sides opposite these 3 angles. For the side opposite angle A, which is the line segment through these points, through these vertices B and C, we represent that side by a small letter A. Small letter A is the side opposite angle A. For the side opposite angle B, which is the line segment AC, the line segment through the vertices A and C of the triangle, we represent this side by a small letter B. The second side of this triangle, denoted by B, small letter B, is the side opposite angle B. And the third side of this given triangle, this side which is opposite angle C, the side opposite angle C is the line segment through the vertices A and B. We represent this side by a small letter C. Now we write the 6 parts of this triangle using the notations we have just used. the 6 parts of this triangle are the 3 sides. The sides are represented by small letters of the English alphabet. And the 3 sides of this triangle are side A, side B, and the small letter C, the side opposite angle C. The other remaining 3 parts are the 3 angles, and the angles of triangle are represented by capital letters. So for this triangle, the 3 angles are angle A, angle B, and angle C. These are the 6 parts of this triangle. The first 3 parts are the 3 sides, A, small letters A, B, C. The other 3 parts are the 3 angles, denoted by capital letters. So the 3 angles are angle A, angle B, and angle C. Now these 3 angles of any triangle satisfy what is known as the triangle theorem. The triangle theorem says that in any triangle, the sum of these 3 angles of a triangle is equal to 180 degrees. For the proof of the triangle theorem, you may look for the proof of the triangle theorem in any geometry book. Now, the 3 angles of any triangle satisfy what is known as the triangle sum theorem. The triangle sum theorem states that in any triangle, the sum of the measures of the 3 angles of a triangle is 180 degrees. For this particular triangle, the measure of angle A plus the measure of angle B plus the measure of angle C will add up to 180 degrees. If you are interested for the proof of the triangle sum theorem, you may search for the proof of triangle sum theorem in any geometry book. Now we write the triangle sum theorem in symbols using the notations we have used to denote the 3 angles of this triangle. Again, the triangle sum theorem states that in any triangle, the sum of the 3 angles is 180 degrees. So for angle A, the measure of angle A, we denote by this notation, measure of angle A. To the measure of angle A, we add the measure of angle B, which we denote by measure of angle B. And to the sum of the measures of angles A and B, we add the measure of angle C plus the measure of angle C. And the triangle sum theorem states that the sum of the measures of the 3 angles of a triangle is 180 degrees. So M, measure of angle A, plus measure of angle B, plus the measure of angle C equals 180 degrees. Again, the triangle sum theorem states that for any triangle, the sum of the three angles is equal to 180 degrees. Now we will apply the triangle sum theorem to obtain the measures of the angles of two special triangles. These are the equilateral triangle and the isosceles right triangle. We start with the equilateral triangle. An equilateral triangle is a triangle with three congruent sides and three congruent angles. All the three sides of the equilateral triangle have the same measure, and all the three angles of an equilateral triangle have the same measure. Equilateral triangle is usually involved in many problems in trigonometry, and you should know the measures of the three angles of an equilateral triangle. Consider this equilateral triangle. The angles were denoted by capital letters A, B, C, and the sides opposite these three angles are denoted by small letters. The equilateral triangle have 6 parts. The three sides, small letters A, B, C, and the three angles, angles A, B, and C. But equilateral triangle has the property that the three sides are equal. The three sides are congruent. When the three sides are congruent, it means the measures of the three sides are equal. And second property of equilateral triangle, the three angles are congruent, which means that the measures of these three angles A, B, and C are also equal. And we write these two properties of equilateral triangle in symbols using the notations we have used to denote the angles and the sides of this equilateral triangle. The three sides are A, B, and C. An equilateral triangle has three sides congruent. So the measure of side A is equal to the measure of B, and the measure of B is equal to the measure of C. All the three sides are congruent, their measures are equal. This is the first property of equilateral triangle. The second property of equilateral triangle says that the three angles of equilateral triangle are congruent, which means that the measures of A, B, and C are equal. And we write that in symbols. The measure of angle A, denoted by measure of angle A, is equal to the measure of, angle B. Measure of angle B. And the measures of angle A and angle B are equal to the measure of the third angle C. Measure of angle C. These are the two properties of an equilateral triangle. Now, using this equilateral triangle, we write the triangle sum theorem. It says that the sum of the measures of the three angles of a triangle is 180 degrees. In symbols, we write measure of angle A, measure of angle A, plus the measure of angle B, plus the measure of the third angle C, By triangle sum theorem, this sum is equal to 180 degrees. 180 degrees. But by this property of equilateral triangle, measure of angle A is equal to measure of angle B. Measure of angle B is equal to measure of angle C. So you can replace measure of angle B by measure of angle A, since this measure of angle B is equal to measure of angle A. And we write measure of angle A, measure of angle B by property of equilateral triangle is equal to measure of angle A. So measure of angle B can be replaced by measure of angle A plus measure of angle C. The measure of angle C is equal to measure of angle B, but measure of angle B is equal to measure of angle A. And by transitive property of equality, we can say that measure of angle C is equal to measure of angle A. Again, by property of equilateral triangle, measure of angle C is equal to measure of angle B. And measure of angle B is equal to measure of angle A. So by transitive property of equality, we say that measure of angle C is equal to measure of angle A. In this equation now, we can replace measure of angle C by measure of angle A. And this sum is still equal to 180 degrees. And by addition of algebraic expression in algebra, measure of angle A plus measure of angle A plus measure of angle A, that means we have added measure of angle A to itself 3 times. So the sum of measure of angle A plus measure of angle A plus measure of angle A is equal to 3 times the measure of angle A. And this is equal to 180 degrees. From this equation, we can now obtain the measure of angle A by dividing both sides of this equation by 3. We divide the left side by 3, and we divide the right side by 3. From the left side, 3 will cancel out because 3 divided by 3 is 1. And we get the left side simplifies to measure of angle A. And the measure of angle A is equal to 180 degrees divided by 3. And that's 60 degrees. So the measure of angle A is 60 degrees. And in equilateral triangle, the measure of A is equal to the measure of B. All the 3 angles are equal. So in this equilateral triangle, all the 3 angles, angle A, angle B, and angle C, they are all equal to 60 degrees. In the second property, we write measure of angle A equals measure of angle B equals measure of angle C equals equals 60 degrees. We have just shown that in an equilateral triangle, the measure of each of the three equal angles is 60 degrees. You should remember that for any equilateral triangle, the measures of the three angles of an equilateral triangle are equal, and the measure of each angle of an equilateral triangle is 60 degrees. Now we will apply the same triangle sum theorem to get the measures of the angles of an isosceles right triangle. An isosceles right triangle is a right triangle, and a right triangle is a triangle with one angle equal to 90 degrees. That means a right angle is an angle whose measure is 90 degrees, and one of the angles of a right triangle is fixed at 90 degrees. In addition, an isosceles right triangle, in addition to being a right triangle and having an angle of 90 degrees, the two sides of an isosceles right triangle are congruent. If an equilateral triangle has three congruent sides, the isosceles right triangle has two congruent sides, which means that the two sides of an isosceles right triangle are equal. The measures of the two sides of an isosceles right triangle are equal. Additionally, an isosceles right triangle has the property that the angles opposite the congruent sides of an isosceles right triangle are also congruent, which means that the measures of the two angles opposite the sides of an isosceles right triangle are equal. Now we will apply to get the measures of the two congruent angles of an isosceles right triangle using the triangle sum theorem. We consider this isosceles right triangle. The three angles have been denoted by capital letters A, B, and C. And we write the right angle at vertex C. That means angle C is a right angle, which means that the measure of angle C is 90 degrees. An isosceles triangle has the following properties. The first property, because an isosceles right triangle is a right triangle, one of its angle is fixed at 90 degrees. And in this example, we take the angle C as the right angle, which means that the measure of angle C is 90 degrees. We write number 1, the first property of isosceles right triangle. One of the angles is a right angle. So the measure of that angle is 90 degrees. And in this example, we take angle C as the right angle. So the measure of angle C is 90 degrees. The second property of isosceles right triangle is that it has two congruent sides, which means that the measures of the two congruent sides of an isosceles right triangle are equal. In this example, we take this side, the line segment through the vertices A and C, and this side, the line segment through the vertices B and C as the congruent sides. This side, this line segment through the vertices B and C, which is opposite the angle A, we denote by a small letter A. And this side of this isosceles right triangle, the line segment through the vertices A and C, which is opposite angle B, we denote by a small letter P. And as I said, we take these two sides as the congruent sides of this isosceles right triangle. So the second property of an isosceles right triangle using this isosceles right triangle is the two sides of an isosceles right triangle are congruent. In this example, A, the measure of this side A and the measure of this side B are equal. We write A equals B. The third property of an isosceles right triangle is that the angles opposite these two congruent sides of an isosceles right triangle are also congruent. The angle opposite small a is angle A. The angle opposite side B is angle B. And the third property of an isosceles right triangle is that angle A and angle B are congruent. These two angles, the angles opposite the congruent sides, are also congruent, which means that the measure of angle A is equal to the measure of angle B. And we write that as the third property of isosceles right triangle, measure of the angle opposite small a, measure of angle A, is equal to the measure of the angle opposite side B, angle capital B. So the measure of angle A is equal to measure of angle B. These are the three properties of an isosceles right triangle. And using the triangle sum theorem and the first and the last properties of isosceles right triangle, we can obtain the measures of the two congruent angles of an isosceles right triangle. And we do that now by triangle sum theorem. The sum of the measures of angles A, B, and C is equal to 180 degrees. We write measure of angle A plus the measure of angle B plus the measure of angle C. The sum of the three angles in the isosceles right triangle is 180 degrees. But the measure of angle B is equal to the measure of angle A. In this equation, we can replace measure of angle B by measure of angle A, since measure of angle B is equal to measure of angle A. We will write this equation in terms of the measure of angle A. We retain the first term, measure of angle A, plus we now replace measure of angle B with measure of angle A, since measure of angle B is equal to measure of angle A. Measure of angle B is equal to measure of angle A. Plus, by the first property of isosceles right triangle, the measure of one of the angles is a right angle, and the measure of the right angle is 90 degrees. In our example, we take the angle C as the right angle, hence the measure of angle C is 90 degrees. So we replace in this equation measure of angle C with 90 degrees. And from this equation, we can obtain the measure of angle A by solving this equation for measure of angle A. In solving an equation, we transpose all the constant terms to one side of the equation. In this equation, we transpose 90 degrees to the right side. And for the left side, we add measure of angle A plus measure of angle A. This means we add measure of angle A to itself 2 times. So measure of angle A plus measure of angle A equals 2 times measure of angle A is equal to, at the right side we have 180 degrees, and we transpose the positive 90 degrees to the right side of the equation. And you know the rule, when you transpose a term to the other side of the equation, you take the opposite side of the term you will transpose. If we transpose positive 90 degrees to the right side, then we write negative 90 degrees. And we simplify the last equation to get the measure of angle A. We have 2 times the measure of angle A, 2 times the measure of angle A is equal to, at the right we have 180 minus 90 equals 90 degrees. And from this equation, we can now readily solve for the measure of angle A by dividing both sides of the equation by 2. We divide the left side of the last equation by 2, and we divide the other side, the right hand side of the equation, by 2. From the left side, 2 will cancel out, and we simply get measure of angle A equals 90 degrees divided by 2 equals 45 degrees. So the measure of angle A equals 45 degrees. But since the measure of angle A and the measure of angle B are equal, the measure of angle B is also 45 degrees. Therefore, in an isosceles right triangle, the three angles are 90 degrees, 45 degrees, and 45 degrees. Again, in an isosceles right triangle, the three angles of an isosceles right triangle are 90 degrees for the right angle, and for the two congruent angles opposite the two congruent sides, the measure of each congruent angle is 45 degrees. And this is true for any isosceles right triangle. Additionally, the congruent angles of an isosceles right triangle are also known as the base angles. So angle A and angle B are known as the base angles of this isosceles right triangle. And the base angles of an isosceles right triangle are congruent, which means the measures of the base angles of an isosceles right triangle are equal. And the measure of each base angle of an isosceles right triangle is 45 degrees. That's our introduction to our course, Trigonometry. In Lesson 2, we will start with solution of right triangles. If you have any questions for today's lesson, you can write your question in the comments section below. But don't forget to subscribe to my YouTube channel, Art Kalisan. I hope you learned something from the lesson today on Introduction to Trigonometry. Thank you.